Hey, hi everyone. In this video, we'll talk about MCP servers and we'll actually build one. We'll also build an MCP client and see how we can communicate with the client server and actually execute the tools that we want through MCP. So it's going to be an interesting tutorial. We'll also see like little bit of details on MCP, like other than tools, what all things can we do. So let me just quickly show you the MCP docs first. Yeah, so this is like the docs that I have been referring to. It's amazing. It also feels a little incomplete at the point for it to be like a standard. But yeah, let's just at least learn about it. It's maybe growing. Maybe we can all contribute. You can contribute as well so that it actually becomes a standard. So here what they say is there's like the client would connect to every single server. So there can be like multiple MCP servers. So let's say Google Maps release their own MCP server, Slack releases their own MCP servers, which will have their own tools and everything will be integrated. So any client that we write or any client that exists that supports MCP can just connect to any of these existing servers that are already running, and it will have access to all the tools automatically. At a very broad level, that is how MCP is simplifying our lives. It's nothing like complicated as such. It's just you're anyways going to write the tools, so let someone else write the tool for you, the tool execution part, and the LLMs can just tell like which tools to execute, and it will actually execute. Maybe it will get more concrete when we actually build our own server. Let's actually jump into building the MCP server directly. I've set up this very minimal code. So I've been following Python SDK for this. You can also look for examples and all. So if you want to write a server and if you want to start running the server, so we just import fast MCP and then we just initialize this fast MCP server and we just run it. That's like simple as it gets. There is this type of transport that is mentioned. We'll discuss a little bit about this, but at a very high level, in this MCP we define tools. So in this server we have added just one tool, which is of course the addition tool, because we are not creative enough to give examples about tools. So this tool just takes two numbers, adds it and returns the result. Magic, right? So this tool is a black box to us. It adds numbers and we don't know how it does it. So the clients can access this tool however they want. You can see like in this MCP server, we can define like more tools here, more tools in terms of like however, like whatever functionality you want to give, you can define one by one. And then all of these tools will be available to the client without them needing to code these tools themselves. And of course, this is the description that it takes. So this is the description that goes to LLM, which will decide if this tool should be called or not. So about the transport part, right now there are two ways we can define the server in. So SSE is one way, and then STDIO is another way. Let me just go through this concepts and then transport. So if you see here, they are saying like one is this STDIO, standard input output, and standard input output is where you prefer running the server on your local. It can handle like the local level of tool calling. So if you want to execute any command line on your local machine, or if you want to tweak any files on the local system, so in that case this STDIO is useful. And then SSE is something where you can host this MCP server and you can communicate it with HTTP post requests. So what this means is this MCP server can be running on a cloud, and any client can just communicate to it on the cloud, like while it's running on the cloud itself. They don't have to get the server code or worry about anything. What I found is like we only need SSE. I mean, even if it's local, the things that they are claiming, we can still set up a local server which runs on localhost through HTTP, and we can still do everything in SSE itself. So that's why I'm a little bit biased towards SSE. I mean, this STDIO can actually be deprecated, is what I feel, but you can have your opinions. I'll just show you how we can do this through SSE, but you can just go ahead and change this to STDIO, and that's it. Like the transport will change to STDIO. On the client side, it's a little different on how you'll handle STDIO. So just be careful about it. So for now, we'll build an SSE MCP server, and we'll also build a client for SSE MCP server itself. Yeah, so that is all the server code that we need with just one tool that we have. We can actually start running the server and it'll run on localhost. So let's just see the client code as well. It depends actually on the way that you want to build your client. And on what application you're building this on. But I'll just show you the MCP part of it. So this client will talk to this localhost server on 8000 port. That is the default port that this server will run on. And we have to give the path as /sse because that is the default one. I think we can change it. There's some arguments here. I was going and checking inside this, but it seems like there is no proper way of doing it. Maybe I am wrong or maybe I didn't get it. But of course, you can change the library itself, hardcode values. There is localhost somewhere that I saw here. Or maybe I'll have to go within SSE and all. But yeah, let's go with default for now. Just keep in mind, you can change the port and the path that you want accordingly. It's just hard coded somewhere within the library, and that's why I'm saying like it's not very mature. Maybe some people can contribute, maybe I can contribute, but I'm too lazy for that. So there's your chance, go contribute. But yeah, by default this server will run on localhost 8000 port. And this is how this is the path that you'll use to connect to the server. And then we'll initialize this session, basically connect to the server. And then we are calling this list tools API on the session to get the list of tools. And since we know that add is one of the tools that we have, so this add function is one of the tools that we have in our server, we can call this, we can do call tool and we'll call this add tool with arguments a is 4 and b is 5. So it takes in two arguments, a and b, so we can get like the addition of these two numbers. And this is just an async function that runs. Let's actually start running. Yeah, so the conda environment is activated. It's called copy in my case. I'll just start running the server with MCP server.py. Yeah, just like that, the MCP server is running on local. Let me open another terminal, and here I'll run the client that we have. Great, so our client ran, it executed these commands and it stopped. So let's see what it printed. If I can decode this a little. So this is the list of tools that we got. Here we have tools, and then name is add, description, input schema. Yeah, great. So this is the list of tools that we are getting from our MCP server. This is the result of when we call this add tool with these arguments. Now of course we'll have to go within this content to actually get the actual result. So we can do something like content, and then I guess this is 0.text. Let me save this and let me run the client again. Yeah, now you can see only 9 is printed. That means that's the result of adding 4 and 5. So you see this client is communicating with the MCP server, and in MCP server I've added this print statement. So let's also go, okay. So in the server also we are getting these logs. So we had called this 2 times from the client, one while we didn't print it properly, and second time when we printed it properly. So we have gotten this 2 logs in the server as well. The whole point is that the actual tool is getting executed on the server side, and this can be deployed on the cloud or anywhere. But the client does not have to worry about the functionality of the tool that it calls. So that is the kind of the beauty of MCP, you can say. So you only have to worry about writing this client. If you're building an application based on LLMs and you want to run tools, you can just do list tools, which will give you the list of tools. And using this list, you can actually create this list of tools in OpenAI format to give it to your LLM. So that is the only coding that you'll have to do. And that too, like, it's only one-time activity. So you'll have to just integrate this MCP tool with your client that you're building, your LLM application that you're building. So in case like Cursor or Claude Desktop, they had already done this integration. And once they do it, it's finalized. So any server can be added. Now we are talking to this local host, but you can imagine like we can put in any URL here which has its MCP server running, and you don't have to worry about anything. It will still give you the list of tools, and we can actually call any of the tools that we want from this list depending on what our LLM asks us to call. That is where the beauty lies. Basically what is happening is, while designing these LLM applications, we were only writing these tool integrations as well, but with this MCP, it's kind of shifting towards the service providers themselves. So what do I mean is, like, if Google Maps are providing some services, then it's on Google Maps themselves to get their MCP server running if they want, with specific tools that they want, so that AI applications can be integrated with their MCP server. Once server is up on the client side, we don't have to do anything. We just have to maybe change this URL or add another URL. So we can have like multiple servers getting connected in our client, and we can get the list, shove it in our LLM tool section, and our LLMs will be free to call any of these tools as well. There is one small caveat. It has this description of the tool, but it does not have description for parameters or arguments. Maybe I'm missing this, or maybe there's some way to do it and I didn't figure out. If someone finds it, please put it somewhere in the comments, I guess. Or yeah, you're free to go and contribute as well to the SDKs if you want. I also want to show you one more thing. Like, since MCP can execute your tools, we can also use MCPs for other things. So let me come here in server developer. So down here they have mentioned, so here they are saying MCP servers can provide three main types of capabilities: resources, tools, and prompts. We just saw like how we can use MCP servers for tools, but it can also be used for something like resources and prompts. Basically, it can have a list of resources which you can access from your client by specifying the exact resource that you want. So it's resources, something like file-like data that your LLM application might need. We'll see an example of this and it'll be clear. And prompts are just these templates or pre-written prompts that you have that you can get to your client through these servers as well. We'll see examples of both of these things as well. So let's go to our server and let me add few more things here rather than just one tool. Okay, so I've added like two resources here. This is how you can define resources as well in your server. So now this is the key to the resource, or the URI as they call it. And then using this URI from client side, you can access this resource. So this is just a text right now, but this can be like a company data or a file data that you want to send to your client for LLM to process it or something. But yeah, like, since executing tool is one thing that MCP is anyways doing, these are also some things that they have added so that it supports LLM better. There can be dynamic resources as well. So for example, like, this is the URI, but dynamically we can also send variables which can be included in the resource string, and that gets sent back. And then we have prompts, of course, like you can define some prompts or templates in your MCP server. So this is like the review code prompt that we have. Please review this code, and then code is given as an argument here. This is a simple prompt, and then you can also return like list of these message types, so that you can parse this and set up your user assistant like separation in the messages in prompt if you want. Let's run our server with these. Actually, I haven't saved the file. Yeah, so I'm running the server now with these resources and prompts defined along with our tool. So our server is getting a little big now, which is good. We want our server to serve more functionalities, right? And not just add numbers. We'll come to the client and we'll see like how we can actually access these resources and prompts that we have defined in our server now. So just like list tools and actually call tool, we also have something like list resources and list prompts. Let me paste the code here for listing resources. So listing resources, we'll get list of resources that the server can give away. And then read resources is the way to use it to actually get the resource that we want from our server. So let's run this code. I have commented out the tool part for now, so it will only print out resource related things. The server is running. Let's run the client and see. Great. So if I can make sense of this, resources are printed here. So list of resources are printed here. We get this static resource in here, and then Yeah, this is another thing I found. Dynamic resources are not being fetched when you call list resources for some reason. So what do I mean is this greeting resource is not given away in the list. So if someone can help me, like, am I doing something wrong, or is this a bug in MCP SDK? You're free to figure out, maybe help me in the comments, or you can go contribute to the MCP SDK as well if it's a bug. So in our list it only says this resource is available, which is fine, but we can read resources using this URI, and then content is given as this. Any static data can be returned. I wanted to see like if our dynamic resource actually works or not. So let me just call this URI as well. Let me see what name to put. I feel comfortable with my name itself. So let me just put Yash here. So we have dynamically added a value called Yash as the name, and then we are calling this resource. Let's call the client, and it says content hello Yash. So the dynamic resource also works. It will take the name and it will return this string, which is hello and name. This resource is definitely registered, but it's not coming in get list when we call the get list API. Not sure if this is a bug or this is the intended, or am I messing something up here. But yeah, this is all about resources. We'll also quickly see about prompts. By now you would have guessed it, like there are these APIs like list prompt and then get prompt, and then in the get prompt you can use the name of the prompt that you want. In this case we are fetching this review code prompt, and argument in code we are saying like, hey, this is the code which you want to review. Let's save this and let's run our client. Great, so we are getting list of prompts here. If you can see this list, we have review code in our list and we have debug error in our prompt list. So here we get properly like 2 prompts that our server can serve, and then we are calling this review code from here to fetch this prompt, and then this is the prompt that it gives us. I think by default it gives us as user role, but we are getting this prompt which we have defined, like please review this code, and then we have added this code here which was sent by the client itself. So this also works. Let's quickly use the other prompt as well. What's the name? Debug error, and then argument is error. So let's send an error code here. Let's type in like the most silliest form of error that can happen. Great, let's run the client now. So we are getting this prompt now. This was the earlier prompt that was printed for code review, and then this is the debug prompt that we are getting from the server. So we have role user. Okay, so by default it's adding this role user, and then I think I don't know, like maybe this can be a workaround, or this needs to be a feature that needs to be added. Like adding if list is present, then don't add it like under role user, but right now it's adding every single message under role user, and it's adding this text from the list. So something that is happening, but even with these bugs, right, like we can handle these bugs on the client end as well. If you just want a workaround, like you can parse this, because this info we are still getting here within the text. This is user, and this is assistant. So if it's I hope it's readable. So here we are getting text assistant and then actual assistant message. So we can still parse it and create our own message so that client works. I mean, yeah, like you need not worry too much about this. Even with the tool calls, right? Like if you say these tools, they don't have descriptions for each of these args, we can still do like list tools, and then if we know what the args or what the descriptions for the arguments are, before giving it to the LLM in OpenAI format, we can add our own descriptions. That's like having MCP server but not having it at the same time to some extent. But yeah, like there are workarounds we can tweak and twist and turn and still make it work. But yeah, I hope you understood how we can make these clients. These are just functions that we'll call. There will be like actual LLM completion APIs that we call. So something like completion API, and then you'll send in the messages. So some list of messages, and then while sending tools here, like this list will actually come from list tools. here, and then with this completion API will return some LLM response, and this LLM response we'll see like if it contains a tool call, then we'll actually call that tool using that name. We'll use this session dot await session dot tool call to actually call that tool, and the arguments that our LLM asks us to fill in. So this will come from LLM, and these will come from LLM itself, and that's it. Like, your tool will be called through server. Once you build this client, once you write this code, it'll stay in the client, and then you can keep adding MCP servers, or you can keep or others can keep adding tools in their servers, so that like this list tool will send like more elaborate tools, and then this code will also work as is, because the name is anyways dynamic, whatever LLM asks you to call. Yeah, hopefully I made it simpler rather than complicated, and hopefully you understood like how to build an MCP server and a client. I'll see you in some next video. Thanks guys, bye.